the gravitational field and potential near the Earth. Show that the gravitational potential at the Earth's equator is about 6.25 times 10 to the 7 joules per kilogram. So we're using the gravitational potential in a radial field equation. So that's minus gm over r. Being careful, this is not an r squared because this is the potential equation, not the gravitational field strength equation. So that's minus 6.67 times 10 to the minus 11 multiplied by the mass of the Earth. So 6.0 times 10 to the 24 divided by the radius of the Earth at the equator. So that's 6.38 times 10 to the 6. We do this calculation, we get minus 6.25 times 10 to the 7 joules per kilogram. B, show the magnitude of the gravitational potential at one of the poles is about 1.003 times the magnitude at the equator. So there's various different ways to do this. One would be to work out a new value and then divide the two. But what might be quicker is if we say the magnitude of the gravitational potential at the poles over the equator. On the top half, we've got G minus Gm over the radius at the pole. At the bottom, we've got minus Gm over the radius at the equator. So here we can see that the G's and the M's going to cancel out, as will the minus sign. We've got 1 over the radius of the pole over 1 over the radius at the equator. So if we correct our fractions here, we've got fractions over fractions. We should end up with the radius at the pole over the radius at the equator. So that should just be equal to 6.3, sorry, let's correct this, they're both 1 over, aren't they? Sorry, the radius at the equator over the radius at the pole. So this should be 6.38 over 6.36, which is 1.003. Explain why the gravitational potential is always negative. So this is to do with the way it's defined. So the gravitational potential is defined as the energy per kilogram to move an object from infinity to a point in the field. But if we picture this situation, if I've got my planet here and I'm taking an object that's infinitely far away and moving it in this direction, then the work done will be negative because there is a force pulling it in this direction. There is a gravitational force pulling it in this direction. So the work that I do in this move is negative. And in fact, the truth will be when I try to move it back in this direction again, that's when I'll have to put in a positive amount of work in order to move it in this direction. So the energy to move away from the planet is clearly going to be positive. So the energy moved in towards the planet must be negative. A better phrase than energy here would be work done. So gravitational potential is defined as the work done per kilogram to move an object from infinity to a point in a field.